Greetings and welcome to this lesson where we are looking at the Science Paper 2. Science Paper 2, this is the chemistry. And this paper was written in November 2024. So we are looking at the specific question, which is question P5. If you are new to this channel, make sure that you follow, you subscribe, and also you share the video so that we can reach more people. Right, so this question is under chemical reactions. This is under chemical reaction, and chemical reaction, I always tell my students, this is one of the topics that you need to understand fully, because this is a topic where you get 3 marks, because it's a simple topic to understand. If you need extra lessons, online or physical, you can visit us. The number is in the comment section there. All right, so what are they saying? They are saying states the collision theory in relation to chemical reaction. Okay, so you need to understand that for a reaction to occur, the reacting particles needs to collide with each other. And for an effective collision, they need to have enough energy. So as they collide, the collision should be in correct orientations. So collision theory states that for a reaction to take place, the reactant particles must collide with each other, and they should have sufficient energy. And this collision must be in correct orientation. That's what collision theory talks about. Okay. B. Lumps of calcium carbonate reacted with 5 cubic centimeter of 0.25 molar, that is the concentration of hydrochloric acid, to produce carbon dioxide gas, water, and calcium chloride, which is a salt. Okay, so the following graph shows the volume of carbon dioxide gas that was collected in a chemical reaction. So this is our graph there. So when you look at this reaction is the reaction of calcium carbonate, which is a metal carbonate, reacting with an acid. So when a metal carbonate reacts with an acid, 3 things should be given out: salt, water, and a gas. That gas needs to be carbon dioxide gas. So don't forget this reaction. Okay, so this graph was observed. So what are they saying? On this same graph, we need to draw another curve that would be obtained if at all powdered calcium carbonate was used. All right, so this graph, lumps of calcium carbonate were used. So look at this. So this graph, lumps of calcium carbonate was used. Now they want us to draw another curve where now powdered calcium carbonate is used. So you're going to draw another curve. Okay, so let me be this side. Okay, so this curve is powdered. This curve is lab. So we have 2 curves there. So this reaction is faster than this reaction. Why? Because using lamps, the reaction becomes slow. But when you are using powdered, the reaction becomes fast. Look at this example. Let's say we get a yogurt or a lollipop. I don't know how they call it. This is a solid yogurt or a lollipop. Why? And then we get the same, we crush it into smaller pieces. The same yogurt, we just crush it into smaller pieces. Then we Of course, time has to be there. That's why even this scale has time. When we set time, we give a person to lick this to lick this lollipop, then the other one licks these smaller particles. So you understand that the person with these smaller particles is going to finish first. This other one to take time to finish fast. Why? Because the smaller the reaction, the smaller the particle size, the faster the reaction is going to be. Same applies. We get the same lollipop, we put in a liquid. We get the same, put in a liquid. Then we observe our times. You will discover that this one will finish fast or will dissolve fast. This other one will take time for it to dissolve. That's why here, when you look at these two graphs, on this curve, the reaction came to an end somewhere there. But when this powder, the reaction came to an end somewhere there where the graph is flattened. So this reaction came to an end faster than this reaction. So we are saying that when we are using amounts of calcium carbonate, the reaction will be very slow. But when you are using powdered calcium carbonate, the reaction becomes fast. So this is the curve that I've drawn for powdered. Okay, what are they saying? Explain how particle size increase the rate of chemical reaction. How does the particle size increase the rates of chemical reaction? Like I'm explaining, the smaller the particle size, the faster the reaction is going to be. This is because smaller particle size will provide a large surface area for a reaction. That's why even during digestion, that's the reason why we chew, you masticate, you crush the food into smaller pieces, then you swallow so that digestion can take place. So smaller particle size, they provide a large surface area for the reaction. As a result, the reaction will be fast. So when the particle size are reduced, like here, this was lumps, here was powdered. Reducing the particle size will increase the surface area. As a result, the reaction is going to be fast. So the smaller particle size provides a large surface area. As a result, the reaction will be fast. Larger particle size, like the lumps, results into a slower reaction. And the reaction, of course, will be slow. So you need to understand that there are other factors that affect the rate of reaction. Apart from particle size, we also have concentration. We also have temperature and pressure, though pressure only affects if the reacting particles are in gaseous states. So this is basically what we need to understand on the rates of chemical reactions. So this question was 2024 uh, November exam under the ECZ curriculum. Thank you for watching. God bless.